morning, grade 9s. This is lesson 3. So we're going to start with chemical equations to represent reactions on page 83. So we use models to represent reactions. This is because it's hard to picture a reaction just in our brain, just on our own. So we put it down on paper and we use drawings and equations with your arrows to show exactly what's happening, and it makes it easier to see and understand. So in a chemical reaction, we have reactants. Reactants are the things that will react together to create what we want. What we want is called the product because the reactants react together to give us our product. So for hydrogen and oxygen, those are our reactants, and they give us our product, water. So different models are used to represent atoms of different elements. Then using symbols for formula to represent reactions. So how will we know what's happening in a formula if we just have all the same symbols? We're going to have H plus O2 plus equals H2O. So now we know it's hydrogen, oxygen, and gives us water. But now if you look on your notes and in your book, there's little green numbers by your symbols, just little ones at the bottom. Those represent the number of atoms of an element in a compound, where the big red letters in front of the whole element or compound represent the ratio in which the molecules react. So the red numbers, those will be used during balancing chemical equations, but that will be during lesson 4. We're going to start that. But just to keep it in mind whilst you're doing this section, know that we're going to be using it during balancing. It's the ratio of the molecules used in the reaction. Diatomic elements. Oxygen gas and hydrogen gas are often used in chemical reactions. So in nature, these come as a pair of 2. So it just happens like that. It's nature, they come as 2. But now there are very specific diatomic elements, like O2. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They are all diatomic molecules. So there'll be H2 for hydrogen, or F2 for fluorine, or Br2 for bromine. So they occur naturally in nature as 2, as a pair. So you always have that little 2, like we saw on the page before, it was in green. We always have that little 2. And as we saw on the page before, our oxygen had O2. So we already started using our diatomic molecules before we even learned about them. Then atoms are conserved during a reaction. Energy, I don't know if you know, but energy is never lost. Energy is just transferred. It's the same as atoms. Atoms are never lost. They just change or move or go away to somewhere else they never are destroyed. So during a chemical reaction, atoms are not lost or gained. The original atom is the reactants are simply rearranged to form new groups of atoms in the product. So if you have 3 hydrogen atoms and 3 oxygen atoms, you're still going to have 6 at the end. They're just going to be rearranged to make it look like water. You don't get now 7 in the product or 5 in the product. It's impossible to lose or gain an atom during a chemical reaction. So I know this was a quick lesson. It's only 2 pages, but I'm trying to ease you guys in, and I want to do a whole lesson on balanced equations on its own, because it'll take quick and then you can have the rest of your week to do topic 6 revision. And I'd like to chat about balanced equations on our Skype session as well. So I'm giving you activity 11 on page 85. Remember to always ask if you need help. I think you guys should be good, and email me when you need your answers or marked. Thank you. Enjoy your day.